So, as I was saying, recursion is just a function that calls itself within that function. You can see that this is the factorial function declared here is calling itself, but with what a smaller argument, n minus 1. So now let us quickly demonstrate something. I want you to follow along. Where is that code again? Okay, let me go back to the main. Okay, you guys didn't see this one, and nobody complained. I was trying to show this. So recursion is a programming
Yeah, I didn't
pattern,
say anything.
but you didn't complain. I just discovered now that I wasn't sharing it. So
Well,
can you see it now? Can you see this definition, recursion? It's a yes or no answer, please.
yes,
No, sir. Definitely, I can't send definition. Okay, I'm saying.
You are saying now, okay. So recursion is a programming pattern or concept embedded in many programming languages, and JavaScript is not left out. It is a feature used in creating a function that keeps calling itself, but with a smaller input every consecutive time until the code's desired result from the start is achieved. Let's quickly demonstrate it before we call it a day. Now, let's declare a factorial function. Factorial. Is there anyone who does not know what a factorial is now? Is there anyone in the class who does not know what factorial is?
No, sir.
Joshua, do you know what a factorial is?
yes,
Joshua, do you
yes,
know
sir.
what a factorial is?
I do.
Can you compute the factorial of 4 for me? Just tell me the expression.
Well,
How do you compute the factorial of 4?
uh, 4 question mark equals to 4 times 3.
It's not question mark, please.
I mean, not question mark, I mean exclamation mark.
Exclamation mark is a symbol for factorial.
Yeah.
So, and what is it equal to?
4 times 3 times 2 times 1.
Yes. So now, let's try to write a function that I think I've done it before instead of wasting my time. Let me see. Um,
So could you show us the recursion, the recursion tab on your computer?
you made the definition.
Yeah, the definition, please.
This one.
Um, yes. Uh,
I believe you have internet, right? You
yeah,
can even
yeah.
you can easily type this on the internet and find out.
Oh, wait, I just need to see it again.
Okay. I'm saying so because of our time.
Uh, I think I have it.
Okay. So can I go now?
Email them.
Um oh, where did I put this stuff again? It's not here. Um, I know I've done before. I don't want to waste my time again doing something I've done before. Algorithm. It's algorithm. It's only algorithms. Classwork. JavaScript. Classwork. JavaScript. JavaScript. Where's JavaScript here? Yeah, this one. This. So factorial. Now, first, look at this. Let me just copy this out and run. Let's see. Go. Yes. Factorial of 7. Can, can somebody compute this for me? Sharp, sharp. Okay, let me just do 6 that I know of. 120. No, 5 rather. 5 should be 120. Yes. So it's working. Now, this code, this function is not recursion. Now, let me explain this code for you, to you rather. Now, you can see I created a variable called result. Are you following me?
So the factor of 5 is 120.
You said?
The factor of 5 is 120.
Yes, 120, yes. So now, can you all see my code?
Yes,
Yes,
sir.
sir.
Good. I created a variable called result, then declare a function, factorial, with just a parameter n, which simply means any number, right? Now, whatever this number is, I used the for loop, right? And inside the for loop, if I tested, I tested if n is equal to 0 or n is equal to 1, automatically just return this result, because the reason is very simple. The factorial of 0 is always equal to 1, and the factorial of 1 is also equal to 1. And that is what this is doing here, this one, right? So I had to test if this number input, whatever number is there, is it equal to 0? If it is equal to 0, just return 1. No need to go further. Just return 1. And if this number input is 1, right, just return 1. Return 1. However, if the input is not 1, in this case, if I say 0 here, it should return me 1. And if I say 1, the factorial of 1 is also 1, right? So, but however, if it is any number apart from 1, say 2, this should return me 2. And the moment this condition is not satisfied, it will come here. It will now do what? Keep multiplying the result. This is what is, let me explain what is going on here. Where is my pencil again? Yes. Already I have 1 here. Assuming that I have 2, so 2 is right here. So I have 1 here, 1 multiplied by 2. I store that number, the result into this. So in this result here, I have 2 at the moment. After computing this, I reduce the value of what? N by 1. And I come here. Since N is now 1 here, at this point, I come here to test. What's it called? Is M greater than 1? Because remember, I've assigned what? N to M here. Let me repeat. I don't want to confuse you guys. Let me repeat. Let me start from the beginning. N is 2. I've assigned 2 to M here, right? So at that point, M has the value of 2. So, and I checked the condition. Is 2 greater than 1? Yes, it is true. 2 is greater than 1. And because this is true, I enter into this code block here. So I checked. Is my N equal to 0 or N equal to 1? These two return false. So I skip this and I enter into this code block here. So N is 2. Result is 1. 1 multiplied by 2 is 2. So 2 is stored into this result now. And I reduce 2 by 1. So my N at this stage, N has the value of 1. And as loop works, right, M, which was 2, also is reduced by 1. So M now has the value of 1. So I check the condition again. Is 1 greater than 1? No, it's false. And because it's false, the function will exit. And that is how 2 is returned when the code is run here. 2 is returned. If I say 3, for example, 3, let's go through the code again. So now N is 3. So here, this is 3. N is 3 here. At this point, I assign N, the value of N to M. So M is what? M is holding the value of 3. Is 3 greater than 1? Yes, it comes in there. Is my 3 equal to 0? No. Is my 3 equal to 1? No. I skip this code block. I come here. This is 3. N is 3. The result is 1 here. So 3 multiplied by 1 is 3. So at this point, result is holding the value of what? 3, no longer 1. Because I have assigned 3 into this result here. Now, at this point, N is still 3. But at this level, N is now 2. Because remember this operator, minus minus, it reduces the value by 1. So N is now 2. So I go back because it's a loop. Once I get to this level, to this point, to this point rather, here, to this point, I loop again. So M minus minus means that I'm reducing the value of M by what? By 1. So my M is no longer 3, but now 2. So I check, is 2 greater than 1? Yes, 2 is greater than 1. So I enter into this loop. But at this time, What is the value of n? Remember, n is 2 here. N is 2. So 2 is not equal to 0. So I skip here, I come here. So at this point in time, my n is 2. What is my result? Who can tell me what the value of result is here at this point? Who can tell me the value of the result at this point?
The value of 2, 6.
No, here at this point here, the value of result here.
Right, excuse me.
Hmm? Favor.
Sir,
What is the value of result at this point here?
um, sir, I got lost.
You are not following.
Yes, sir.
The value of result is 3 at this point. So this expression is now computed 3 times 2, 6. So 6 is now assigned to result back again here. So at this point, result is now 6, no longer 3. At this point, because 3 times 2 is assigned. So we know that n is 2, but because of this operator now, it is now further reduced by 1. So n is no longer 2, but 1. N is now 1. It will get here and it will now go back and loop. What is the value of m before coming here? The value of m is 2. So because of this operator, it will reduce it by what? 1 again. So it will check, is 1 greater than 1? Is 1 greater than 1? No, that is false. It will exit this loop, this for loop, and you now come here. It now print result. And what is value of result is 6. So 6 will now be printed to the console here. If you run it, you will see 6 printed. And that is how you write. There are many different ways you can use to do this. You can even use an array to achieve this. Different ways. So I have to explain it to you before going into recursion. So now, if I go to recursion, I think I've done it. I did it somewhere here. This one. Let me just copy 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 it because of my time. Now, listen carefully. Let me go back to the definition here. It says recursion is a function. This function that keeps calling itself here. Is factorial. I do not need to name it factorial. I can name it Joshua. See, remember, this is just a variable name, but I must change it here. It can be anything. So here, if I want to calculate a factorial of what? of, so here I will say Joshua. Factorial of 5, Joshua. I call my function Joshua. I run, it gives me 120. So it is not about me giving it a factorial nomenclature, right? But remember, in programming, when you are naming your variable, you give it a meaningful name. And that is the reason why I called my function factorial. I can't call it Joshua. Joshua is the name of a person. So I will say factorial. That is a proper way, the naming convention. I only demonstrated that to you to tell you that it is not compulsory to call it. Maybe, for example, you want to find, you write a program to calculate the square root of a number. It is not compulsory you call your function a square root. You can call it any name, but remember, the best practice is for you to give your variable a meaningful name. So now, if you look at this, the same thing happens here. The factorial of 0 is 1, factorial of 1 is 1. So that means that if I have any value 0, I should have 1. Or factorial of 1 there, I should have 1. So it has to return 1. So that means that the moment n is equal to 0 or 1, just return 1. This n. So let me now demonstrate at this point in time. So let's say we want to calculate the factorial of 3, for example. Or let's start with 2. Okay, let me start with 1. 1 first. Or better say 0. Where's my pen? So now, at this point in time, I'm calling the factorial function, right? Yes or no? Yes or no?
Yes, sir.
Let me remove
Yes,
these
sir.
distractions. Let me just remove all these all other ones. So I'm calling the factorial here, which is this one. Excuse me, please. What is the value of n? Anyone?
0.
Yes, the value of n is 0. So at this point in time, n is 0. And the moment I called my function, it will come into this code block. It will test, excuse me, is n equal to 0? Yes, n is equal to 0. So 1 is returned. It won't even get to this code block. If I run it, you have 1 there. Let's go again with the value of 1. So what is the value of n now at this point in time?
1.
1. N is 1. So it will come into this code block because I'm calling the function. It will test, is n equal 0? No. This, remember, is or. Is n equals 0 or n equal 1? But n is equal to 1. So this code block will run. So 1 will be returned. It will not come here. It will stop right here to return 1. If I run the code, you will see 1 is returned. Let's go to 2. This is where it's getting. Now listen carefully here. N is now 2. Am I right?
Yes, sir.
Yes,
N
sir.
is 2. So when I call the function with the argument 2, it will come into this code block. It will check, is 2 equal 0? No. Is 2 equal 1? No. So it will skip this code block. It will come here. It will come into this code block. Now listen carefully. N is 2 right here. Yes or no?
Yes.
Speak out. I see, for me to know
Did,
you are confident of the answer.
did you say N is 2?
Yes.
Um,
Is N 2 at this point in time?
yeah.
Good. N is 2. So let me bring it out properly. N is 2. Multiply. Now, the function at this point is now calling itself. This is where the recursion is happening. So now, N is 2. 2 minus 1 is what? 1. So what is happening here now is that the factorial function is now receiving an argument of 1. Because at this point, N is 2 minus 1. So 2 minus 1 is what? 1. And that brings us back to this place where it says that keeps calling itself but with a smaller input every consecutive time. So
So
you can,
mean,
you said?
what does it mean by with a smaller input? Does it mean that if you numbers bigger, or if you if you get a result, would your result be smaller than what you tested?
Yes. What this is saying is that when the outer function, this one, this is the main function, is calling itself, the argument here, the value of the argument must be smaller than the previous one. You know, here at this point, N was 2. And that is why you have N being 2 here. But remember that what is being passed into this function internally is 2 minus 1. And what is 2 minus 1? Joshua?
Two.
Hmm?
1.
1. So you can see now that 1, where's my pen? You can see that 1 is smaller than the 2 here. Yes or no?
Yes.
Yes. So that is what this means. It is a feature used in creating. We create a function here, and that function keeps calling itself, but with a smaller input. 1 is smaller than 2. Is it clear now?
Yeah,
Can I go on?
you can.
Okay. So now at this point in time, This function is being called again. It's being called again. At this point, it's being called again, but with an argument of 1. So at this point, n is no longer 2, but 1. So n is 1. Is 1 equal 0? No. N is 1. Is 1 equal 1? Yes, true. Remember, this is an OR operator. If any one is true, a single one is true, then it will enter and execute this code block. So because n is equal to 1 here, so it will return 1. Remember, when we return, we go out of whatever code block or loop or function. It will exit totally. So this call is now going to return 1. It's like returning 1 back here. So this 1 is now brought down here. 1. 2 times 1, which is 2. So because this is now a return word, so 2, it will now be returned. If I run this code, you will see 2 on the console. Now I'm going to use one last example because of our time. We have 4 minutes to 9. Let us use 4 in this case. We know that the factorial of 4 is 4 times 3 times 2 times 1, which is equal to 24. This is 12 times 2, 24. So n is 4 at that point in time. It goes into the code. 4 equals 0, no. 4 equals 1, no. It will exit. It will exit. It will not execute anything here. It will come, it will jump right here. N is 4. So let me bring it down here. N is 4 times. This function is calling itself with 4 minus 1. So invariably, what that means is that I'm calling the factorial function, but this time with argument 3. This is a factorial function. So at this point in time, n is no longer 4, but now 3. So n no longer 4, but now 3. So it will check, is 3 equals 0? No. 3 equals 1? No. It will skip this and come down here. N is 3. This one will give me 3 times 3. This n is 3 at this point, times. Now it's going to call the factorial function again. And this time, it will now be what? 3 minus 1. Remember, n is 3. So n is 3 here. 3 minus 1. So instead of saying factorial 3, I'm going to have factorial 3 minus 1, which is 2. Don't let me scatter it. Let me just return it back. Initially is 3. Here is now calling factorial 2 because 3 minus 1 is what? 2. Now, I'm calling this factorial function again here. So n is no longer 3, but 2. So it will come here in again. Is 2 equals 0? No. Is 2 equal 1? No. It will come here again. 2 is n. This now will give me 2 times 2 times factorial. I'm calling the factorial again. This is what the recursive is all about. So I'm calling the factorial again. So this time 2 minus 1. And 2 minus 1 is 1. So I'm calling factorial with argument 1. I'll call this function again. N is now 1. So 1 here. So it will check, is 1 equal 0? Nope. Is 1 equal 1? Yes, it is true. So this will now be executed. So 1 is now returned. So 1 is returned. So it will now calculate 1 times 2 is 2. This will return me 2. 2 times 3 is 6. Now, 6 times 4. Remember, there's 4 years. 6 times 4. This will give me 24. And that's why when I run this, I will have 24. Is there any question?
Sir, is that the question?
Okay.
Um, how come the the code keeps starting from the beginning, even when there's no loop?
Will you please ask your question again?
How come after you do return n times factorial n minus 1,
Mm-hmm.
how come it goes to the beginning to start again and says function
Good.
check, not check n again?
Thank you.
Then when it's not a loop?
Yes, thank you for that question. Now, remember that function is just like a servant. Function will go and do the biddings of the caller. And we now come back to the caller with the results. Who called factorial 1 here? It is this code here, this code. This code here called factorial 1. So after calling factorial 1, it returned 1 here. So 1 times 2 is 2. Who called factorial 2? It is this code here. So 2 times 2 is what? Abi? Yes.
2 times 2 is 4.
No. This is 1. This is 1.
Yeah, 2 times 2 is...
Aha. So this is a caller, right? This is the one that called, that resulted into this. Let me repeat. Let me just repeat. Let me see. Okay, let me just try to clean this up. Yeah. Clean this up. Let's go back. Okay. Let me clean everything. 4. This factorial 4, let me write it out here. I call factorial 4 here. Factorial 4. This is the caller, factorial 4. So this one comes in here, gets here, now met with this, which means it met with 4 times factorial. Now, 4 minus 1 is 3, factorial 3. Who is, and by the time this finishes executing, who is the caller? This is the caller. It will return the value to this caller. But however, remember, this has not fully resolved. This factorial 3 will now go again and call this expression. At this time, it's now 3. N is 3. 3 times factorial 2. Because this is now 3 minus 1, which is 2. So who is responsible for this call? It is this factorial 3. This has not fully resolved. It will call again. N is 2. 2 times factorial 1. Factorial 1 will now fully resolve to 1 because it's going to return 1. So 1 is now returned. So that means this factorial 1 is being replaced by 1. By 1. Because 1 is returned. So 1 times 2 is 2. So this 2 will be returned to the caller, which is this one, 2. So factorial 2 is now being replaced by 2. So 2 times 3 is 6. So 6 will be returned. Remember, returned. So 6 will be returned. Who is the caller? Factorial 3 will now be replaced by 6. 6 times 4, 24. Who is the caller? Factorial 4. Who is now replaced by what? 24. And this factorial 4 is now 24. Yeah. So it's like saying console.log 24. So 24 is now printed out. The return value or return expression, it will always be returned back to the caller of that function. Favor, any question? Do you understand?
Yes, I understand how it's repeating itself now. But please, sir, can you explain again from when you said 1 factorial 1 is responsible for calling 1? Please, can you
Okay.
explain from?
Okay. Now, at this point, factorial 1 is calling the function again, right? Am I right? Yeah. Because n is now 1. So it will call this function. So n is 1. So because n is 1 and is equal to 1, 1 will be returned. So this one has resolved into 1 here. Is there any other function call here? No, there's no other function call. Yes or no?
Yes, sir. No, no
Who
other function.
no other function call. So this one will be returned to the caller. This is the person that called this factorial of n. So one, this is now replaced. So 1 times 2 is 2. Who called this expression? Who called it? It's factorial 2 that called it. Factorial 2 is the one responsible for this call. So 2 is now returned back to the caller. So 2 replaces factorial 2 here. 2 times 3 is 6. Who called this expression? Is factorial 3. So 6 is returned to the caller. Six times 4 is 24. Who called this expression? Who called it? It's factorial 4. So 24 is returned back to the caller. So this is now replaced by 24. And 24 is now here because this is factorial 4, 24. Okay, let's do it this way. Because over time, I will go over this factorial again in the next class. Because I need to demonstrate how to resolve the issue or the issue of that calling of objects. Where is it again? Because okay, let me clear the screen. Clear. Because I wrote it here also. See, where is it again? I think I have it somewhere. Flatten any object. See, if I copy this and I come here, let me just clean. Okay, let me just comment this one out. Just want to demonstrate to you. Now, if I copy, let me go back to that data. Okay. First, let me do what we did before here. I think this is it. Const employee. I assign that. It's an object. So, and I will now call my function here. If I run my code, you will see everything, the data printed out. Just look at how simple this is, just because of what? Recursion. This is the function name. You can see exactly the function name here is recursion. Recursion makes your work kind of abridged. It abridges your work. Instead of writing loop, the moment you discover in your algorithm that exactly the same process is being repeated, but in a smaller version, just know that you are in a recursive algorithm. You can see how miniature this is kind of miniaturized. instead of the long loop that I demonstrated last week. That was done for demonstration's sake, for you to understand how to maneuver objects. So this is recursion. Now, okay, let me copy everything. Look at how massive this data is. Let me just copy everything. Let me copy everything. Replace this object. Now, you can see that I am not changing anything in my what's it called, in my code, right? I will just copy the data, get the data variable. That is all. That's all I need to do. Then call my function. If I run it, it's going to print everything out without me changing anything in my logic, in my algorithm. I'm not changing anything. So call it out. So that is what's it called? Recursion is doing. So let's call it a date here. I know the recursion might give you a little tough time to get, but I only want you to understand one thing. The one thing is that the caller of function we always receive the return value. Return value. If a function, let me say x, is called, and within this function, an expression is called, maybe x squared plus function, maybe x minus 1 again. And this one we now call again. We call the main function. It will return whatever value is here, which is x minus 1 now, square, plus whatever function again. So this one is calling this expression, whatever is returned, we return back to this guy. Then whatever calculation is done here is returned to this guy, to the first caller. Caller of a function gets the return value. All right, so let's close it here today. I want you to review this recording, review it again, prepare down your question towards Saturday. All right, thank you. Hope
Thank you,
there's
sir.
no other question. No question? Going, 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 gone.
No.
All right. Thank you. See you on Saturday.